Okay, so if you're watching the video, you're doing this chapter, whatever, from Chem 20 question as a warm-up. So page 282, question 18, and it says that lead nitrate and sodium iodide together react to form a yellow precipitate and a solution, maybe it says, I don't know, and then it gives this information. And you need to be reading this and push pause so you can do it at home on your own. Those of us that did it, you set it up like this. Graham and Havey, I don't know if you did unit analysis or down the column. Okay, and Graham?
I think I did that.
Down the column or a unit analysis?
Just unit.
So do you have one big long equation that you're typing in?
No.
No, okay, so you should be able to find, and Havey, if you did it in one big long thing, then tell me if you can't follow along, and I will do it in the big long thing. Okay, so the first thing that everybody did in the room would have been to multiply these two things together. 0.100 moles per liter times 25.0 mils. This will give us the number of moles of my PbNO3. And so multiplying those together, I get 2.500 millimoles. Why millimoles? Because the milliliters and the liters cancel out, I'm left with milli and moles. What's my mole? So then to go across the bridge, we used to say, so down the stream, across the bridge. To cross the bridge, I have to look at my mole ratio, right? It's a 2-to-1 mole ratio. So for every one of these, I need 2 of those. So for every 2.5 of these, I need 5 of those. How did you figure that out? You multiplied by 2. So times 2 to get your number of moles of your NaI. So NaI will be 5.00 millimoles. Now I'm in this column here. Okay, so whereas you just got this times 2 moles divided by 1 mole times 1 over. So for the rest of us that are formula followers, the volume is going to be N divided by C, where this is the N, so 5.00. Divided by the C is 0.125. This is millimoles. This is moles per liter. So what cancels out? Moles. What am I left with? Milliliters. And you get, what is 5 divided by this? 0.125? What's your answer? 40 milliliters, I believe, if I remember from period 2. Okay? That way I don't need to convert and then convert back. 40 mils. Everybody happy with that? Everybody remember that from Chem 20. Okay? And then I think C asks you to calculate the mass of precipitate that would have formed. Correct? And so you use this number of moles, but now it's a 1-to-1 mole ratio. So this number of moles is 2.5 millimoles as well, and your mass is equal to, well, your number of moles times the big M of PBI, whatever that ends up being. And what did you girls get for your final answer? 1.15 grams. Did everybody else get 1.15 grams that got that far in your warm-up? You didn't get that far, or you didn't get it?
I didn't get that far.
You didn't get that far, okay. Okay? That, although it's probably rusty for those of you, especially those of you that haven't taken chemistry for a whole year, but certainly those that haven't taken it for a semester, that might be rusty, but it shouldn't feel unfamiliar, it shouldn't feel scary anymore, and maybe you just need to practice speeding up with it. But everything should be okay. This was like a good chunk of Chem 20, right? Yes? Okay, so your package that we're going to follow today about titrations involves this. Why? Because stoichiometry and titrations were linked when we were doing concentration and volume. Do you remember that from Chem 20? Okay, so where's my projector? Doll. Anybody see it? Okay, so grab your packages out for your titrations. And the first bit of that package is just, the first bit of that package is just titrations. and some definitions that you hopefully committed to memory last year, but probably didn't. So, okay. In a titration, one reagent called the titrant, which is in the burette, memorize it, burette, memorize it, titrant, is slowly added to the sample in the Erlenmeyer flask, which you probably used a pipette to get it in there. Remember all these words coming to you? You okay, Nick?
Yeah.
Okay. Until an abrupt change in solution property, like a color change. Remember the color changes? And now we call that the end point of the experiment. Everybody remember this? Okay, so in Chem 20 you did a lot of acid and base. And we added some phenolphthalein indicator to indicate the point in which the pH changed. Do you remember that? Okay. And so here, though, with our redox titrations, we often have a colored sample already. So do you remember yesterday I did a demo for you where I took some orange potassium permanganate and it turned green? Do you remember that? Mm-hmm. Imagine that one was in the burette and the other was in an Erlenmeyer flask. Erlenmeyer flask? Yeah, that's what I mean. And eventually it would turn orange to green. So it's got its own self-indicating point. Does that make sense? So if in the burette I have some purple potassium permanganate and I'm adding that purple drip by drip to a solution, okay? Whatever's in this sample will be giving its electrons to the purple. It reacts colorless. Oh, so the sample is still the original color. Let's call it colorless for lack of imagination. So add a drop of purple, the purple reacts, stays colorless. The whole thing stays colorless. Add a drop of purple, the purple reacts because the electrons were given by the sample, stays colorless. When the sample's all gone, when the chemical I have in the sample is all gone, it can't give its electrons anymore. If it can't give its electrons anymore, this reaction can't happen. So you add 1 drop of purple, and the solution turns wrong. Darn.
Wrong.
Pink.
Oh.
I said wrong. Wrong.
Wrong.
What did you do on the weekend, Gabby?
No.
It turns pink. Why pink and not purple? Yeah. Yeah. Why? What did you say?
It's diluted.
Because it's diluted. Yes, of course it turns purple, but you got 1 drop of purple in a whole ocean of a sample there. So overall it's quite dilute, and therefore it's a pink color. Okay, so you got to remember that dilution because that'll trick you. What color should the endpoint be? And you'll be like, purple, no, pink. Okay, just like I tricked you, but don't be tricked on the diploma. So when all the samples reacted, 1 extra drop, all of this says what I just explained to you about 1 drop react, 1 drop react, 1 drop light purple. There it is. Oh, light pink, I said. Okay, happy with all those terms and all that information? Yes? And then on the other side of this sheet, I have, another definition, the end point. The end point and equivalence point are quite similar. The only difference is when I'm talking about equivalence point, I'm talking about not when it equals, but when the mole ratio is true. Do you remember in Chem 20, one of the questions was always like, what's the mole ratio of these 2 samples? So in your example that we just did for a warm-up, the mole ratio of the 2 things considered were 1 to 2. So the equivalence point is when you have 1 to 2, or 2.5 to 5. That's when they are equivalent in their ratio, not equal. Okay, so that's what equivalence point is, and equivalence point happens at the end point. So this is the sort of the theory, equivalence point, and end point is about the actual solutions stopping the reaction. Okay, when you end the reaction. Do you understand the difference? Because they're the same, but they're not. To make things nice and easy. Another normal one that we use that is also self-indicating, or turns color in the middle of the reaction, is this dichromate ion. This is the one I showed you yesterday. Dichromate ion was orange. I acidified it. You watched it react with the hydrogen peroxide, which must have given it electrons, and it turned green. So this is what you saw last day. And do you remember where you find these colors of all these ions? Some of them you'll see so often and talk about so often you'll have memorized, like purple to colorless and orange to green. I'm going to say these like a million times. But what about the difference between an Fe2 plus and an Fe3 plus ion? They are different colors. Spot on. Where do you find it? Page 11 of your text of your data booklets. Tells you all the colors you'll need to know. Okay?
So will we be using all of these, or like will there be just a few in general that we use quite often?
You're going to use these two examples a lot. So then it'll be a waste of your time to look it up because you should have these memorized by the time we're done. Okay? But some of the obscure ones, like iron 2 and iron 3, you don't use very often. So you might want to look those ones up.
So will it always be like a constant 1 mole, or is it always going to alter?
It's going to alter. And so you just have to think if it's concentrated dilute on that thing, that sheet. Okay? In order to perform stoichiometry, the results of the titration of the concentrated titrant must be known. So what you've got in your burette has to be a standard solution. You have to know its concentration. So what's a standard solution? You know its concentration. Good annotating out there. Well done. And if it's not a standard solution, if you don't know its concentration, you have to do a titration on it in order to get it to be standardized, in order to do your titration that you want to do. Okay? Or sometimes to standardize it to more decimal points. Because you might have bought this solution and it might say 0.1 molar, but you want 3 significant digits in your answer. So because you are working on pharmaceuticals and you need to make sure that that drug is precisely that concentration, not 0.149. That's too high. 0.100 is what you want. So you might need to do a titration before you do a titration. Okay? Happy? All right. So that's still all, except for the color changes, self-indicating color, it's still Chem 20. Everybody feeling comfortable still? Because it's about to get crazy. Okay. All right, next page. Let me turn this around. Oh, no. Oh, I have no idea how to get rid of that now. Previous view? No. Rotate. 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 Okay. Okay, so here's the biggest problem with students and titration. They see all these words and they go, words, this is chemistry, I'm not reading. And they don't. Okay? Aha, says Gabby, the linguist, or the humanities in the room. Okay. So it's really important that you read all the words because there's information hidden in them. And you'll be like, I don't know what they're reacting it with. And I'll be like, well, did you read the question? Okay? So we must read it. What is the concentration of chromium-2 ions in a solution obtained from the analysis of a stainless steel fork? That part doesn't probably really matter. A certain concentration of potassium permanganate solution is titrated to oxidize that volume of chromium-2, and you're already falling asleep, to chromium-3 ions in an acidic solution. Okay, so where did we start with our Chem 20 example that you did for a warm-up? Where did we start? Because we're going to start at the same spot. Write an equation. So this isn't an easy equation to be had, because it's not like these two things added together and you've got to precipitate. I don't see that, right? You see what you saw last week. I see a bunch of species that I'm going to identify, and my strongest oxidizing agent is going to, and my strongest reducing agent is going to, and I'm going to write the half reactions down, I'm going to get a net reaction. See how this ties in the Chem 30 aspect? Okay? So I'm just going to scroll up here. So what are the species present that I have? K plus and MnO4 minus. What else do I have present?
H2O.
Okay, H2O, because it's a solution. H plus, because it's acidic. And then we've all conveniently avoided this bit in the middle. Chromium-2 ions to chromium-3 ions. What do I have?
Chromium ion.
I only have chromium 2. I am oxidizing the chromium 2. And it is producing the chromium 3. Can you pick that out of there? Okay, so I'm starting with chromium 2 ions. And I'm producing 2 yield arrow equals whatever chromium 3 plus. Okay? See that? And do you need to look up in your data booklet the strongest and strongest, or do you think you could write that half reaction without even thinking? What side do the electrons go on?
On the right.
The right. And how many electrons?
1.
Yeah. And guess what? I don't even think this half reaction is in your data booklet. They've told you what it becomes so that you don't have to look it up. Because A, it might not be there, or B, it takes too long to look it up. So here's one half reaction. Everybody okay with that? There's one half reaction. What's the other half reaction?
KMnO4.
You bet, it'll be this one. We've seen it already half a dozen times. Those two things together are definitely going to be my strongest oxidizing agent. Okay, so here's my strongest reducing agent. How do I know? Because it tells me that that changes. So it must have been. Okay. So I've got Cr2 plus becoming Cr3 plus 1 electron according to the question. This is a loss of electrons, which is oxidation, and therefore it's my reducing agent. And therefore it must be my strongest reducing agent. Then I've got my, look it up in the book, MnO4 minus and 8 H pluses and 5 electrons. I'm doing this by memory. Somebody tell me if I'm wrong. 2 plus and 4 waters. And therefore it's my gain of electrons, which is reduction oxidizing agent. Aha, here's the Chem 30 bit, right? This is Chem 30 last week. List your species, strongest, right them beside each other. What was the next step that we had to do after we wrote down our half reactions?
Make the net reaction.
Balance the electrons. So I've got 1 electron here and 5 electrons there, so I need to multiply this by 5. And then my net reaction is going to be 5 Cr2 pluses, and MnO4 minus 8 H pluses goes to 5 Cr3 pluses, Mn2 plus, and 4 waters. Just double check because it's so long that I don't need to cancel anything else out. I don't. This is my net. There's the Chem 30 bit that ties in with the Chem 20 bit. Okay, now that I have my balanced chemical reaction, like I did in my warm-up, I'm now going to list my put my information underneath the columns. Right? So what information have I been given? I'm just going to erase all this stuff so that I can see it again. What information have been given? That this is the concentration of this. What does this have to do with this? Ah. Do you remember in Chem 20 writing this down? Potassium permanganate aqueous will dissociate into a K plus and an MnO4 minus. Do you remember doing that? Remember doing that? And do you remember 1 mole per liter of this dissociates into 1 mole per liter of this and 1 mole per liter of that? Do you remember that? And if there's a little 2 here, become a big 2 here, which would mean 2 moles per liter of that. Remember doing that? So here I have not 1 mole, but 0.0114. So therefore of this I have 0.0114, and of this I have 0.0114. I don't really care about the K plus because it's a spectator, but I do notice that this thing is, right there. So when it says 0.0114 moles per liter of potassium permanganate, and I know that it's a 1-to-1 ratio, I can just go ahead and write down the concentration is 0.0114 moles per liter of the permanganate. With me? Gabriella?
Yeah.
Turn to the sheet. Okay. What's this volume pertain to?
The chromium 2 to chromium 3.
So which one in the column?
CR.
Javin?
2.
CR2 plus. So my volume is 25.0 mils. What other information am I given?
The final initial bit.
Well done for reading the title of this. We're also given volumes of potassium permanganate. So these are the volumes of KMnO4, or in our case, we're just concerned about the MnO4 minus. Okay? Do you remember what you're supposed to do with a table like this? Find the average of all of them, all the time?
Well, except for the...
No.
You're supposed to the ones that are the closest to each other.
Right, if there's one that's completely different, within 0.2 mils, we exclude it. It's an overshot. Do you remember that? Or undershot. Okay, so subtract these two, and you'll end up with 11.5. Subtract these two, you end up with 11.1, 11.2, and 11.1. Sorry, this is a 2 and this is a 1. So, can you see one that has been overshot? The first one, and so I do not include it in my average. But 11.2 plus 11.1 plus 11.1, all divided by 3, will give me an average of 11.13 repeating mils. And what is that applied to? The volume of the permanganate. V equals 11.13 mils. With me? What's the question?
What's the concentration?
Okay, all the way up there. What's the concentration of chromium 2? C equals question mark. And now, finally, it looks just like Chem 20, right? And you guys are already on your way, I can see. So the first thing we're going to do, for those of you that don't know, is you're going to take C times V of the known there. So 0.0114 times 11.13. 1-to-5 ratio, so I'm going to multiply that by 5 eventually. And then the volume here ends up being 1 over 25.0 mils. And tappity tap, the concentration is so Gabby, this is going down the column, this is crossing the bridge with the 5-to-1 ratio, and then I'll get my number of moles of my MnO4, and then this will help with this volume there. Figure that out. I honestly can't remember what you get.
25.764.
25.764.
moles per liter.
764. That's not what we got last class. What'd you get, Samantha?
I got 36. I got
Woo.
25.
Hey, wow. Right, let's try this again. 0.0114 times 11.1333333 repeating times 5 over 1 divided by 25. Concentration is 0.0254 moles per liter. Those of you that said 25 are converting one side and not the other. You converted 1 mil and you didn't convert the other. Danger Bay. Don't convert either of them. They're going to cancel out. Do you guys remember Danger Bay?
No, what?
It's like this show when I was growing. It's like old school. It's funny, you should watch it. It's about some family in Vancouver. island. Yeah, Danger Bay. Go look it up. Anyway.
Is yours in moles per liter or is yours in millimoles?
Mine's in moles per liter because the milliliters will have cancelled out, leaving me with just moles per liter. If you've got 2 mils, you don't have to do either of them. Okay. Happy? Not really? Or okay. So a lot of Chem 20 in there, and then the Chem 30 bit. So first of all, this part here, down and across and down, is the easy Chem 20. This part here, interpreting, reading, figuring out what the table is difficult Chem 20. And the coming up of the net formula is the new Chem 30 bit. See how they all piece together here? Okay? So nothing on here is new. Nothing on here is new. In fact, actually, this chromium 2+ to 3+ is from like the very first package of this unit. Okay, so nothing new here. But putting it all together is hard. Lots of balls to juggle here. So it's probably going to feel a little bit shaky, but just practice. Okay? So we can do, I'd like you to circle. I'd like you to do this problem 2, please. Okay, you're going to do that one. And then you're going to, after that, flip the page. And you're going to do this one, 15H. Read. I'm going to say that for this one. Read it. Because you'll be like, I don't know what it is. Read it. Okay, and then 48, please, because that's a lovely one to do. And that's probably enough to get us started, but we will be, just in case you're not here tomorrow or something, doing this question 1 and this question 2 as well.